All right, on these last problems here, I want to solve the equation. Here's what it doesn't say. I want to solve the equation by putting the equation in factored form. I also want to solve the equation by first setting everything equal to 0. So to be able to put things in a factored form of the polynomial, you need to set things equal to 0 first. Okay, so number 19. Here's what we kind of did on the last problems. Factored just 6k squared plus k. And then I didn't have equal to 0, but now I do. So you still want to look for the greatest common factor between 6k squared and k. The greatest common factor is just k. And then here's what you're left with. If you factor out k from 6k squared, you're left with 6k. If you factor out a k from k, you're left with positive 1. Now that's equal to 0. Now it's similar to the examples that we solved where the polynomial was already in factored form. We had to factor this first though. So we use the zero product property, set k equal to 0. That's already solved. We also set 6k plus 1 equal to 0, and we solve that equation. Subtract 1 from each side. 6k is equal to negative 1. And then if we divide each side by 6, k equals negative 1/6. So our two solutions, k equals 0 or k equals negative 1/6. I'm going to go over number 21 next. So you want to look for a greatest common factor since everything's already equal to 0 here between 4z squared and 52z. So the greatest common factor between 4 and 52 is 4. 4 actually goes evenly into 52. And then both of these have a z. The lower exponent is 1. So 4z is the greatest common factor between these two terms. 4z times 1z, or just z, is 4z squared. 4 actually goes into 52. So 4 goes into 52 13 times. And then z times just 1 is z. So I could do 13 times 1. That's just 13. That's equal to 0. Now that we have that factored, set each of the two factors equal to 0. That's using the zero product property. Either 4z equals 0 or z plus 13 equals 0. If I solve the first equation, divide each side by 4, z is equal to 0. Or solve the second equation, subtract 13, z is equal to negative 13. Those are my two solutions. Okay, the next one that I'll cover is number 23. So in order to solve this by factoring, I first want to get everything to one side of the equation. I want to set everything equal to 0. So I could subtract 11s squared from each side. Then it's 22s minus 11s squared is equal to 0. And then I can find the greatest common factor between 22s and negative 11s squared. The greatest common factor between 22 and 11 is 11. They both share an s, and the lower exponent is 1. So if you factor out 11s from 22s, 11 times 2 is 22, and then I don't need anything else because 11s times 2 is 22s minus s. 11s times negative s is negative 11s squared. So then that's equal to 0. Set each of the factors equal to 0. 11s equals 0, or 2 minus s equals 0. Hopefully you can see that's an s and then a 5. If I divide each side by 11 here on the first equation, s, not x, but s is equal to 0. On the second equation, here's what I'm going to do. Like you could subtract 2 and then divide by negative 1. If I just add s to each side, 2 equals s, or s is equal to 2. So the two solutions should be 0 and 2.